Okay, now we're ready to dive into what's probably the most complex piece of the test report, and that is the breakdown of the cortisol and its metabolites. So as we break down the cortisol piece, what we're going to do here is go through a very basic overview of what we're looking at here, and then go through a number of specific examples. So if you want to hang through this first part, we'll understand it at a basic level, and then if you have a more complex set of results, you may want to watch the duration of the video to get a handle on some of these different patterns that you're going to see. So what we're looking at here is the pattern of cortisol, the free cortisol, over time. So you've got your 4 measurements here: the waking sample. And don't mistake that for waking cortisol. It's a waking urine sample, which gives you an idea of the cortisol during the sleeping period. The next sample is taken 2 hours after waking. That's a collection of that time period where there should be a big surge of cortisol in the early morning. Then you can see that there. Then in the late afternoon, and then the bedtime sample. So we take those 4 measurements, we're adding them up for both cortisol and cortisone. Then we've got the total of the metabolites. Metabolized cortisol is your best marker for overall production of cortisol. Remember, the free cortisol is only about 1% of the total. It's the active form, so it's an important measurement. But when you want to know about the total output of the adrenal gland of cortisol, look at the total of the metabolites. And then when we want to look at whether the active cortisol or the inactive cortisone is predominating overall, we look at this gauge that will show you whether there's a predominance for cortisol or a predominance for cortisone. So now let's go through a couple examples of the types of results you might see on this report and explain what that might mean to help with the understanding a little bit. So if, for example, we see elevated levels of free cortisol, elevated levels of free cortisone, we've confirmed that the free cortisol levels are elevated. When we look further at the metabolites, if those are elevated as well, we simply have a situation where there's an abundance of cortisol, right? That's relatively simple. If, however, we have those same levels of free hormone that are relatively elevated, and the metabolites are not elevated, and maybe even in some cases they're on the lower side, that's really a picture of sluggish cortisol metabolism or clearance. So keep in mind, again, the free cortisol is only about 1% of the total. So if you're getting these elevated levels of free cortisol, yet the cortisol is not being excreted as these metabolites readily, again, there's sluggish clearance of this cortisol, and in some cases that might be causing the elevations of the free hormone as the cortisol is not able to be excreted. So the most common situation in which we might see this would be hypothyroidism, and in those situations, again, there's a relationship between thyroid, between liver function, and your ability to get rid of cortisol. So what you typically find in those situations is what the literature says about low thyroid is that not only do you get this slowing of the cortisol clearance, you also get a slowing of cortisol being deactivated to cortisone. So you may see that the free cortisol is a little bit higher than the free cortisone. And you may also see, as you look at the bottom there and look at which metabolites are predominating, that there is a predominance of the cortisol over the cortisone, which again is this picture of making a little bit of cortisol. That's what the metabolites tell us. How much did we make? But then not being able to get rid of it either to cortisone or downstream to those cortisol metabolites for excretion. That would be one particular situation. If we flip that around and look at another situation that's sort of the opposite of that, let's say the free cortisol is low. If the free cortisol is on the lower side, and we see also that the cortisone is lower, we don't have a lot of free hormone. If we then look at the metabolites of cortisol, and those are also low, what have we done? We've confirmed that there's not a lot of cortisol being produced in that situation. Then we want to look further again at the metabolites and see which metabolites are predominating, the cortisol or the cortisone. In a situation like this, if we're favoring cortisol, that's really a picture of somebody sort of hanging on to that cortisol, saying, look, I don't have very much. I'm going to hang on to that cortisol because I need it. On the other hand, if someone has low overall levels and they're really favoring cortisone, now we've got double trouble because they don't have a lot, and what they do have is sort of running away from them, if you will, in that it's being deactivated readily towards cortisone. So they don't have very much, and what they do have is being quickly metabolized. So that's really going to add into a picture of low cortisol in terms of symptomatology, whether it's fatigue or something else related to low cortisol. On the other hand, if you have a patient with these low levels of free hormone, however, you have higher levels or even elevated levels of metabolized cortisol, now you have a picture of, again, remember, the metabolites are your marker for production. So when you see low free cortisol, you don't know that you have low adrenal output of cortisol until you've confirmed with the metabolites. If the metabolites are normal, you have normal cortisol output and low free cortisol. What is that a picture of? That's a picture of elevated cortisol metabolism or clearance. When do we see that? The most common cause of that is probably obesity, but you can also see it in people that are not obese, that have had long-term exposure to glucocorticoids, maybe long-term stress where the body's seen elevated levels of cortisol for time and time again until the body's actually, as a compensatory mechanism, has sped up its ability to get rid of cortisol. If you're being overdosed with thyroid, that'll lead to this sort of a look, because hyperthyroidism increases the liver's clearance of cortisol. And in some cases, you can even see really extreme situations where the free cortisol is actually quite low and the metabolites are quite high, which again, though, don't be mistaking that for a low cortisol situation. Yes, the circulating cortisol appears to be low, but the production is quite elevated and the cortisol metabolism is sometimes greatly upregulated. So we want to look at the free cortisol and the metabolites. If the cortisone is higher than the cortisol, we want to look at the cortisol primarily. That's our first point of data as we're trying to evaluate the up and down pattern throughout the day. The cortisone is there to confirm. Again, if it's the same, then it confirms. If it's a little bit higher, then what it implies is that the cortisol may well be a little bit higher than what the cortisol level itself seems to imply. What that also tells us is that in that local tissue there, the urine's coming from where? The kidney. In the kidney, there is specifically activity that moves cortisol to its inactive form of cortisone, but there isn't a lot of activity that moves it in the other direction. So for cortisone, once it's made in the kidney, if it recirculates as cortisone, how does it get back to cortisol? The liver, fat cells, there are other compartments in the body that more heavily activate the cortisol. So the cortisone, the way we like to say it is the cortisone is sort of a shadow of the cortisol in terms of that up and down pattern throughout the day. So if we look at this particular situation, the cortisol is lower than the cortisone. So we've got a lot of activity in that kidney region that's deactivating the cortisol to cortisone, and then it goes throughout the body. But if we want to know overall which one predominates, we look at the metabolites. So if the metabolites tell that same story and say, yes, there's more of a deactivation to cortisone, then it's a fairly simple interpretation in that overall, we simply have cortisol being shuttled to cortisone. Now, if that happens and the overall levels are low, then it's probably going to add to the picture of low cortisol, fatigue, etc. If it happens when the overall cortisol levels are high, then it's more of a compensatory mechanism likely of getting rid of some of that high cortisol. If, however, in this situation, we have again the cortisone being higher, and then we move down to the metabolites and we see a disagreement that it says that the cortisol is actually favored, this actually makes intuitive sense in that local tissue, the kidney, where the urine's coming from, there's a lot of deactivation. Then it goes throughout the body, and the reactivation to cortisol must be even more active in that we see an overall systemic predominance, not of the cortisone, but of the cortisol. So we must have a very heavy reactivation to cortisol, which we see in situations like inflammation. If people are using things like licorice root extract, that actually blocks the deactivation and pushes overall towards cortisol. So that's one situation. So obviously, with all of the data that we're collecting, cortisol over time, cortisone over time, the total of the metabolites, and then the balance of the metabolites, whether it be predominantly towards cortisol or predominantly towards the inactive form of cortisone. We want to take all this data into consideration, but obviously, given all of that data, there are a lot of different scenarios that we can see. So we want to work through it one section at a time, looking most importantly at the pattern of free cortisol throughout the day, the total of production, the total of those metabolites as a total total of cortisol and cortisone metabolites, and then also whether there's a big imbalance between the active form of cortisol and the inactive form of cortisone. We want to take that all into consideration, overlaying the patient picture with that as well, and that gives you a full and complete picture of the HPA axis and the cortisol production.